Hello everyone, this is Giannis with Ververica, and in this video we'll see together how you can get started with Apache Flink and Apache Paimon. So as you know, Apache Flink is a compute engine for processing both bounded and unbounded data streams, and then Apache Paimon was born in order to provide the streaming storage layer and overall extend Apache Flink's capabilities for doing stream processing directly on the data lake for use cases that sub-second level latency is not really required, and you are good with up to 1 to 3 minutes delays. So we have this repo over here that you can basically clone and get started with. So I'm going to navigate, actually if you check here, first of all, I have downloaded already the source code, and if you check, we have a Docker Compose file here that we're going to use in order to set up a Flink cluster and run all of our code examples. And for the image, we have this Docker file here that basically builds on the Flink 1.17 base image, and all we're doing is we are downloading all the necessary connector dependencies that we'll use. And basically we have the Paimon and Flink jar dependency, we have some Hadoop dependency required, and also the Flink Paimon actions jar file that we are going to use for running some operations. So let me go back here and actually set up my cluster, and I'm going to do that by running Docker Compose up, and soon enough this will go and start my Flink cluster. So if I go back here now and navigate to localhost 1881, I can see my Flink UI. And basically a few things around Flink. We have here the job managers, which is basically the master process of Apache Flink, and we also have the task managers, which is like the worker nodes. And you can check here different metrics for your task managers, and each task managers, basically when they start, they register themselves to the job manager, and they offer the available slots. And as you can see here, we have 5 available slots, which means the maximum level of parallelism each Flink job can have is up to 5. So with this in place, the first thing I want to do is go and create a new terminal and actually spin up a cell inside my job manager to actually go and run a few commands. And the way to do this is by running this docker exec command -it on the job manager container and specify bus. And right now I'm within my job manager container, and you can also see here this is the Paimon Flink's action jar we had downloaded in our Docker image. And if I also check my libs folder inside Flink, you can see I also have the Paimon Flink connector. So overall, our setup is ready. Now the first thing I'm going to do is actually go and launch a Flink SQL client, and this basically allows me to start executing Flink SQL commands against my cluster. So if we go back to our project here, let's open this readme. And first of all, we're going to need some data to play around with. And since we're here on the Flink SQL client, when you're dealing with Flink SQL, the high level of Flink SQL is actually the catalog. And we can see the available catalogs we have by running the show catalogs command. Right now, we're using an in-memory catalog, which means that if we lose our session or close our session here, for example, if I exit this, everything we have created will be lost. And the catalog basically serves for holding metadata about databases and tables, and Basically, when you create a table, let's say, all these metadata are going to be stored within the catalog. And we have two types of catalogs, as we said, the in-memory one and the persistent ones. For now, we're going to use an in-memory catalog, and when we start with Paimon, we'll see that it also offers a persistent catalog. And since I'm here now, inside my catalog, I can also run other commands, and for example, I can run show databases and see the available databases, and you can see we have the default catalog and the default database. And when we create a table and we haven't specified any new catalog or database, everything will be stored here within the default catalog and the default database. So let's go and create our first table and have some data to play with. And so I'm going to create this measurements table that is using a data generator and will be storing information around measurements, for example, the sensor ID and the reading that we have, like a temperature or something. And the data generator is going to generate some random data for us, and we're specifying here that we want it to generate like 1,000 rows per second, and we also then specify, for example, the minimum and maximum values our readings can have, and the same, we're getting a random value between 1,000, between 0 and 1,000 for our sensor IDs. So let's go ahead and create this table now. I'm going to copy paste this command here, and I'm also going to run this command that basically sells the result mode. Basically, this lets Flink knows how we want our results to be output on the screen. I'm choosing a Tableau mode here, but you have a few other options like a table. And let's also see how our data looks like. And I'm going to run a select all statement and provide a limit of 10. Basically, this is the data we're getting. We have our sensor ID and our readings. Now, moving on, we're going to also create a second table that is going to store sensor information. And again, it's going to have a sensor ID. We give a latitude and longitude, a generation type, and the updated timestamp. So if we go and create this table again now, let's go here and see what our data looks like. And you can see we have our sensor ID, latitude, longitude, generation, and the updated timestamp. So at this point, we have some sample data to play with and some streaming data. And when using Flink and Flink SQL, you can do all kinds of operations. So for example, I can go here on my measurements table, and let's say that I want to select the sensor ID, and I also want to calculate, like how many readings its sensor generates. So I'm going to run the select all and count reading from my measurements table, and then I'm going to group by the sensor ID. And you can see we have streaming data, and our results will keep updating every time we have some new readings for its sensor ID. Now, this surrounds Flink, right? And you can do all kinds of stream processing operations. Now, let's switch our focus to Apache Paimon. So with these things in place, we can now switch here on our guide and get started with Paimon. So when we get started with Paimon, first of all, I'm going to set a few configurations here. The first is about setting the checkpoint interval. Now, the checkpoint is basically Flink's mechanism of ensuring fault tolerance. So, for example, here we're saying that every 20 seconds I want you to get to go and get one snapshot of the state and basically keep around all the work that has been done up to this point. So, in case of failure, I know how to recover and basically continue my pipelines from the way it were before the failure, so you can actually recover. And then this is one configuration that is required from Paimon. This is a Flink operator, and we want to disable it only because Paimon doesn't need it and it's quite expensive. So as we said, when we're dealing with Flink SQL, we have the concept of the catalog and all the metadata gets persisted there. So the first thing we're going to do with Paimon is actually go and create the Paimon catalog. And the Paimon catalog is persistent because everything is also stored on disk. So every time, even if we lose our session, our data and metadata will still be kept around. So this is the command for creating a Paimon catalog. And we basically want to give it the connector type and the warehouse path. And because if you check here on our Docker image, we're mounting on our local file system, everything we'll be doing, you will see the results here on our local file system that it's mounted the container. So let me go ahead and create the Paimon catalog. And if we check here now, we can see that the Paimon catalog with the default database has been created. And in order to use Paimon, we need to switch to that catalog and everything will be created in here. Now, the next thing is I'm going to actually go and create a table. And I'm going to create a measurements table to store the data of our measurements inside a Paimon table. And here I'm specifying a bucket. And basically the bucket is the smallest unit of storage in Paimon, and when you want to achieve greater parallelism, let's say, you can create more buckets. And also the bucket key here defines how the data is actually distributed among different buckets, and we can also specify the file format. And here I'm specifying that I want everything to be written on disk as Parquet files, and the default one is ORC. So let's actually go and create our table and see how things look like. At this point I have created a new measurements table, and when we create the table, the first thing that gets generated, as you can see here, is the schema of the table. Up to this point I have no data inside. And you can see that we have the ID of the schema, and we also have fields and their corresponding types, different metadata for the table, and also the options that we have for this particular table. Now, let me go and actually I'm going to set the pipeline name, and now I'm going to store all the data that gets generated inside the measurements table created at first with the data generator inside our measurements table inside Paimon. So before I run this command, one thing to note is that all the data gets stored in Paimon when the checkpointing actually happens. So basically we will get new and fresh data every 20 seconds. So if I go and run this command, it's going, if I go to my Flink web UI here, I can see that I have my job, and the job name is the one specified. And if I click here, you can soon see the job graph and the data that starts being stored inside Apache Paimon. So if I navigate back here now, you can see we have lots of data being generated. And the first thing to know is that we have a snapshot here, and a new snapshot is being created every time that the checkpoint happens, because with this checkpoint new data gets stored on our disk, and each snapshot basically represents how our table looks like at each point in time. And we can also leverage that afterwards if we want, for example, to do things like review how our tables look like at different points in time, if we want to do some time travel, and overall some operations to fix some data corruption. And the snapshot basically is also tied to the manifest file, the manifest files here. We have the manifest list and the manifest files. And basically these are references from the snapshot to the manifest list, which in turn references manifest, and the manifests keep the metadata around the data files we have here. So if I open one file here, you can see, for example, what it looks like inside. Okay, so moving forward, let's also do the same and create a table. Actually, first, let's switch to the batch mode, and let's see our how many measurements we have. Now we're telling Flink by switching to the batch mode that we're not in streaming anymore, so we can actually go and run batch queries. And with every checkpoint that happens, as we said, more data gets generated and more snapshots are created, so we should see our results here also being updated. But if I run this command again, for example, because a new checkpoint hasn't happened yet, you can see we don't get more records. So let me switch back to streaming mode now, and let me also go and create a new table for my sensor information. And again, I'm specifying a primary key this time, and this is going to act as an upsert table, and this means that for its unique key we are only going to have one value, and by default we are only keeping around the latest record for that value. So let me go and run this command again, and similar as before, you can see we have our sensor information here and the schema gets created. So let me set a job name, and also going to store all the information, the sensor information I have inside my Paimon table now. So if I go and run this command and navigate to my Flink web UI, you can see we have a second Flink job be created, and this stores now the sensor information from the table being backed by our data generator to Apache Flink. So once more, if I go back and switch to batch mode, and I go and check how many records I have for my sensor information, you can see that I have 1,000 ones, and basically this is all the sensor IDs I have. So let's switch back to streaming mode now. So what we are going to do now is take the measurements we have, and we're going to run a lookup join to actually enrich the measurements with sensor information and create a new table that we're going to call measurements enrich. And as you can see now, we have the sensor ID and the readings from the measurements table, and we also have data from the sensor information. So let's go and create this new table now. And again, you can see here the new table is being created, and we have the schema for that along with the options. And let's also run a new Flink job now. We're going to perform a lookup join. So this is how the syntax for a lookup join looks like with Flink and Paimon. Basically, we are specifying that we have the measurements table and we want to perform a lookup of the sensor information. And we're also specifying this property here that is required for the lookup join, and it's basically the for system as of syntax. And what this means in practice is that we're taking into account the event time that the time that we have in our measurements table, and basically when we're performing this lookup join, we only are interested in the latest value of the lookup table, and we are joining here on the sensor ID. A few other things to note is that we are using the type hints of Apache Flink, and we specify that we want the lookup join to be synchronous, so we don't block between different records. And we are also here specifying a retry strategy. Apache Paimon supports a retry strategy as well, and we are using it. Why? Because, for example, let's say that we have one measurement, and for some reason the sensor information for that particular sensor hasn't arrived yet. So we'll keep retrying until that record arrives, here specifying that we have a retry strategy for fixed delay, and that delay is 1 second, and we're going to do a maximum of 50 attempts. And we're also specifying here a retry predicate of lookup miss, and we're also allowing unordered events to be output. So if I go and run this should start populating my measurements and reads table. So if I go here, you can see that once more I have one more job being created, the data enrichment lookup join, and it has started processing some records. So if I go back now to my measurements and reads table, I can take a look and I can see that I have all my measurements information and reads with sensor information. So up to this point, we have created different tables in Paimon, and we have performed a lookup join. Now, a few things around operations and Paimon and the table formats overall. Now, if you check here, for example, you can see that we have many different snapshots that are being kept around. And along with that, all the manifest files and manifest list files. And also we have more and more files being created on our directory here. And in practice, many of these files are quite small in size. So when we go and run, let's say, batch queries on these kind of files, because we have way too many files, we're going to have to scan and read many data files. So overall, and because these files actually keep only few records around, it's better to have like larger files and less files. So one thing to do here is that we can also leverage Paimon's system tables. And for example, if we run this, you can see here we have our table, and it has this special files table inside, and this will give us a few metadata around the data files we have in our system. And you can see now that even because we have lots of files, it can be somewhat slow to return results. So these are basically the files that we're interested in. The rest are just reference files that have been set around. So what we can do now? What we can do is we're going to leverage, actually let me open a new terminal here. We're going to use this Flink action charge we have, and we're going to run a compaction process. And the compaction process basically is going to take all the small files that we have here and merge them together into larger ones. And in order to run a compaction job with Paimon, you can run the compaction automatically, but right now we're going to do it manually. And we're going to achieve this by running this command here, and from the jar file, we're going to execute in batch mode, and we're going to run the compact action. So let's go and run this. I have run this, my job has finished, and the compaction was run. But if I go back here now, you can see that nothing really changed. And this is one thing to keep in mind. Nothing changed because by default, you need to set up some expiration times for the snapshots that are being kept around here. And also you need to specify how many snapshots you want to be retained. And because the default configurations for production systems are way more larger, I think it's like close to 1 hour of expiration, we're going first to alter our table and specify that we want to expire all the snapshots that are around for more than 20 seconds, and we want to keep around a maximum of 5 snapshots. And before I run this command, you can check here that I also have a schema file, and the version is 0. So when I go and actually alter my table, basically, if you go back here, you can see that we have a new schema file being generated, and it also contains the new options I have added for my file. So let me also open this for reference. So let's go now and run once more our compaction job and see what happens. Actually, I'm running this from within the Flink SQL client, so let's go and run this here. And good enough, our job has been run. And if I go here, you can see that it removes all the snapshots that don't need to be around anymore and only keeps the relevant data files. So compaction basically is really important when we're dealing with table formats and we want to have good trade-offs between write and read queries. So this is one thing to keep in mind. So this was a quick introduction of how to get started with Apache Flink SQL and also Apache Paimon. I hope you enjoyed this video and stay tuned for more. Thank you.